Hello everyone. Let's look at today's Leetcode problem 2616. Minimize the maximum difference of pairs. Before starting this problem, let us look at a motivational quote for today. A wise a wise person knows even the sun takes a break after lighting up the world. Rest is not laziness, it's preparation. Human energy also, in similar ways, it is not infinite. Rest aligns with uh, biological nature where we perform sleep and our circadian rhythms are to be relaxed and refreshed. Studies show strategic breaks boost focus and prevent decision fatigue. So you're charging for future challenges. Okay, so we should always learn to take breaks, and that's a common thing everybody experiences. Even the greatest people in the world also would like to take breaks at regular intervals. Okay, so let us understand this problem that we have here. You are given a zero indexed integer array nums and an integer p. Find p pairs of indices of nums such that maximum difference amongst all the pairs is minimized. Also ensure no index appears more than once amongst the p pairs. Note that for a pair of elements at the index I and j, the difference of this pair is nums I nums j, where x represents the absolute value of x. Return the minimum maximum difference among all p pairs. We define maximum of an empty set to be 0. Okay, so let us understand how we can solve this problem. So let's say we are given with this input array 10, 1, 7, 1, 3 and p is equals to 2. The first pair is formed from the index 1 and 4. Let's say this is 0, 1, 2, 3, 4, 5. So first pair is between 1 comma 1 and the second pair is formed between 2 comma 5, which is 2 comma 3. And the difference here is 0 minus 1. And this is the value that we are getting, which is 1. And that's the same that we are seeing here. So what we need to do here is it's uh, consider taking sorted array and then taking uh, difference of the pairs such that a difference between two pairs results as a minimum, right? So the maximum difference is max of nums of 1, which is nums of 1 4, which is 0 minus nums of 2. So yeah, uh, minimize the maximum difference of pairs. So we have obviously chosen pairs. We want to minimize the difference of these pairs. So that's the whole goal, and we are returning 1. So looking at this example, so we can approach this problem with couple of ways, where firstly we sort the input array, and so we make this as a sorted array like 1 1 2 3 7 10, and we take the difference, uh, like min difference is sums of 0, and max difference, or the upper bound of difference, will be uh, element will be 9 minus 1 by 2, which will be equal to 4. So we check if there are any possibilities. So our approach, I will write the approach here in a detailed way. So first thing is we sort the array, and we check the mid difference point, and we calculate that by min difference, which is equal to uh, nums of 0 minus max difference, which is equals to the 0th element minus the last element, and from this we divide by 2, so and we check, we set a for loop, we set a while loop, as long as left and left is less than right, where left is 0 and the right is the maximum value, and we check if can form pairs. Nums array and mid difference and p pairs are the input that we want to form p pairs with, and from there, if this is possible, then we change the right value to mid, or we reduce the right pointer to limit our search, and else we check if left is equals to mid plus 1, and we return left value after the binary search. And this function that we have here, can form pairs, this will be helpful for us to return we check for count of how many possible pairs can be formed within this nums array with the consideration of mid difference and p pairs. So we iterate from 0 to nums length, and if nums of I plus 1 minus nums of I is less than mid, then we increase count to plus plus, else we increase I counter, and we simply return if count is greater than or equal to the number of pairs, right? So yeah, okay, so let's try adding in the code for this solution, and let's see if we can solve this. So firstly we sort the nums array, we sorted from small to biggest, and we calculate the left value, which would be 0, and we also calculate the right value, which would be equals to we calculate the mid value of the difference, and we also check if there can be any possible pairs that can be formed with. Else we increase the left value to mid, and at the end we can simply return the left value. Okay, so we might want to add in this function, which is we do not have an increment piece for this for loop, where we increment only if uh, so we increase the I pointer if we do not uh, see a value or a difference between pairs which is less than the mid value that we sent in. And okay, so yeah, and we simply return. Okay, so this should be sufficient. Let's see. So yeah, this is our solution. Let me just. So here what we are doing is we are sorting the array firstly and then checking every time if the left and right values, left value is less than the right value, and we are shifting our difference such that we can find a difference which can be uh, a set of values that can be formed with p pairs, and also we want to do that uh, by checking if it's less than mid value every time in this can form pairs, and we return the left value which would be the specific difference between the two pairs. So can form pairs takes in nums, and the mid value is the difference the difference between the sort difference uh, the minimum the minimum difference minus the maximum difference that we are doing, the midpoint of the difference in the nums sorted array, and we check if the specific elements are worthy such that it can form pairs and we can use it to find the difference. If that's the case, then we return true and we increase the right pointer to right plus mid. Else we right to mid, so we are reducing the mid. We are reducing the right index to the mid value, and we are limiting our searches. Similarly, if we cannot, we are increasing the left pointer to mid plus one and thereby retrying again. So until we get a resulting value which ends up with a left pointer. So time complexity of this solution would be we have a binary search operation which would take log n, and an operation here where we are looping uh, certain times with this function which gets called n times as we are iterating through nums array at the max with nums dot length. So it would be log n plus n. So n log n would be the time complexity of the solution. Okay, so if you found this video helpful, please like and subscribe to my channel. Thank you.